You close your eyes, expecting sleep to take you, but something holds you in place. A quiet disturbance in the fabric of reality. What if the world you trust is built on laws that don't quite make sense? What if space, time, and matter are illusions, barely holding together? You try to dismiss the thought, but physics is not so forgiving. It twists, bends, defies expectation. Nothing is solid, nothing is stable. You are about to fall, not into sleep, but into the unknown. You stand before a wall, solid and unyielding. Logic tells you there is no way through. But what if I told you that, given enough time, you could walk straight through it? No force, no cracks, just pass through. At the quantum level, particles do the impossible. They appear where they shouldn't be, slipping past barriers as if they were never there. A trapped electron, confined by physical laws, suddenly vanishes from one side and reappears on the other. No passage, no in-between, just disappearance and arrival. Your instincts rebel. How can something leap across an impassable gap? How can reality be so disobedient? But this is not an anomaly. It is a rule, one deeply embedded in the very structure of existence. You might think of a particle as a tiny marble, rolling along, colliding with obstacles, but that is an illusion. A particle is not a marble, it is a ghost, a smudge of probability smeared across space. It exists not in one place but in many, a wave of possibilities waiting to be resolved. And sometimes, that wave extends beyond, a barrier, reaching into places it should never be. The equations of quantum mechanics whisper something disturbing. If a particle can exist somewhere, then, no matter how unlikely, it will. The wall before you is not as solid as it seems. It is a thin veil, riddled with cracks at the quantum scale. If your body were as uncertain as an electron, you might wake up one morning on the other side of your bedroom wall, without ever having moved. But it gets worse. The universe itself is bound by probabilities, and quantum tunneling does not just occur at microscopic scales. It is happening everywhere, all the time. The sun, that great burning titan in the sky, should not shine as it does. By classical physics, its nuclear fusion should not work. The protons at its core should repel each other, unable to merge. And yet, they do. They slip past their own barriers, tunneling through forces that should keep them apart. Without this quantum betrayal, the sun would be dark. Life would not exist. And so, you must ask yourself, what is stopping you from tunneling right now? The answer is unsettling. Probability. Your atoms obey the same laws as an electron. If you were to wait long enough, longer than the age of the universe itself, the tiniest fraction of possibility suggests that you could, in fact, tunnel through a wall. The odds are against you, but they are not zero. The barrier is real, but it is also an illusion. And that is the terrifying truth. Nothing is truly impossible. The walls of reality itself are not absolute. They are porous, uncertain. At the deepest level, existence does not follow rules. It dances on the edge of what might be shifting, unpredictable. If the solid ground beneath your feet is nothing more than a probability field, what else is waiting to slip through? What barriers, what boundaries, what laws might suddenly collapse, letting something in or letting something out? And more importantly, if you closed your eyes and let time stretch to infinity, would you wake up somewhere else? Imagine you were given 3 pigeons and only 2 pigeonholes. Logically, at least one pigeonhole must contain 2 pigeons, an unavoidable certainty in our classical world. But in the realm of quantum mechanics, logic begins to fracture. The quantum pigeonhole principle defies the very foundation of common sense. 3 quantum particles can be placed into 2 containers, and yet, impossibly, no 2 particles ever share the same space. The mind strains against this contradiction. How can 3 fit into 2 without any overlap? How can something be divided yet remain apart? In our everyday world, we take for granted that objects obey simple, intuitive rules. If you pour 3 cups of water into 2 glasses, at least 1 glass must contain more than 1 cup. If you distribute 3 chairs between 2 rooms, at least 1 room must have more than 1 chair. And yet, when we enter the quantum world, something eerie happens. The very act of measurement alters reality, carving out possibilities that shouldn't exist. The quantum pigeonhole principle is one such impossibility, one that forces us to reconsider whether place and position even have meaning at the most fundamental level of existence. At the heart of this paradox lies the nature of quantum superposition. Unlike classical objects, quantum particles do not exist in single, definite states. Instead, they exist in probabilities, overlapping possibilities that only resolve into concrete reality when observed. This means that when we attempt to place 3 quantum particles into 2 containers, we are not dealing with tangible objects, but with entanglements of probability waves. These waves interfere with one another, shifting and cancelling in such a way that no 2 particles ever appear to occupy the same space, even though logic dictates that they must. It is as if reality itself is dodging our expectations, rewriting the rules before we can catch it in contradiction. The more we try to measure, the more the universe resists, reshaping its own fabric to defy our assumptions. And so, we find ourselves in a position where 3 things have been divided into 2, yet they refuse to coexist in the same compartment. It is not simply a trick of numbers. It is a deeper rupture in how we understand the very structure of existence. This paradox extends beyond mere thought experiments. It has profound implications for the nature of identity, separability, and even the very idea of objects in the quantum world. If fundamental particles, those that build everything we see, can resist classical grouping, then what does this say about the reality we perceive? If objects on the most basic level cannot be placed, then does placement even exist? Or is it an illusion created by observation? And then the question comes, the one that lingers long after the paradox has been explained. If reality refuses to obey logical separation, then where are you really? If fundamental particles can exist in a state where placement itself is meaningless, then is location, your location, anything more than a fragile illusion? Perhaps even as you sit where you are now, you are not really there. Perhaps you, like the quantum pigeons, are merely a superposition of possibilities scattered across multiple states, waiting for something or someone to collapse you into a single existence. But what if that never happens? What if you, like the paradox itself, are trapped in an unresolved state? A probability wave stretching into the abyss, never truly touching reality. Imagine you are standing before 2 doors. You must choose one. But what if, no matter what you pick, someone could change your past decision after you've made it? What if the very act of observing something in the future could rewrite history itself? This is not a thought experiment. This is the delayed choice quantum eraser, a phenomenon so unsettling, so reality-breaking, that it challenges everything we assume about cause and effect. To understand this paradox, we must begin with the infamous double-slit experiment. Fire a single photon, a tiny particle of light, at a barrier with 2 slits. If you do not observe it, the photon behaves like a wave, passing through both slits at once, and creating an interference pattern on the other side, as if it existed everywhere at once. But if you place a detector at the slits, forcing the photon to choose a path, the wave collapses, and the photon behaves like a particle, passing through only one slit. Observation determines reality. Simply watching changes the outcome. Now, let's make it stranger. In the delayed choice quantum eraser, the experiment is modified. Instead of measuring the photon immediately, we delay the decision. The photon passes through the slits, but its path is not recorded until much later, long after it has already landed on a detection screen. And yet, the results remain eerie. If we later choose to measure which slit the photon passed through, the interference pattern disappears, as if the photon had always behaved like a particle. But if we choose not to measure, the interference pattern remains, as if the photon had always been a wave. The decision is made after the photon has already arrived. But somehow, it retroactively determines what the photon did in the past. It is as if reality rewrites itself, as if history is not fixed but malleable, waiting to be decided. Do you feel the weight of this paradox? The future is influencing the past. Your choices today could be rewriting yesterday. If time is not linear, if causality can be bent, then how can you trust that anything has truly happened the way you remember? This is not philosophy. This is physics. And if observation truly shapes reality, then ask yourself, what unseen forces are watching you? What choices, far beyond your understanding, are erasing and rewriting the world around you? And if you could glimpse that process, if you could see the past reshaping itself in real time, would you ever trust your memories again? You are holding a coin in your hand. You flip it, and before it lands, it is neither heads nor tails. It is both. A paradox of existence, a blur of possibilities suspended in uncertainty. Now imagine that somewhere, light years away, in a distant galaxy, another coin exists. It has no connection to yours, no physical link, no hidden wires. Yet, when your coin lands, so does the other. Not just at the same time, but in the same way, perfectly synchronized. If yours lands on heads, the other will always land on tails, no matter how far apart they are, no matter how much distance stretches between them. They are bound together by something deeper than space, something beyond time itself. This is not magic. This is not a trick. This is quantum entanglement, an eerie, mind-breaking phenomenon where two particles once linked remain inexplicably connected, no matter how far they are separated. A change in one instantly reflects in the other, faster than the speed of light, faster than the universe should allow. The implications are terrifying. Particles do not exist in definite states until they are observed. Before measurement, they hover in a superposition, spinning both up and down, existing in all possible realities at once. But when two particles become entangled, their fates are fused. They are no longer two separate entities, but one shared existence, a ghostly mirroring of each other's state. You could send one particle to the farthest reaches of the cosmos, beyond the edges of human understanding. And yet, the moment you measure the first, the second will instantaneously take on the opposite state. Not after a delay, not after a signal is sent. Immediately, Einstein called it spooky action at a distance, a phrase dripping with unease. He refused to accept it. It violated everything classical physics stood for: causality, locality, the very foundation of what we think reality is. If nothing can travel faster than light, How does one particle know what happens to the other? How does information pass between them without passing through anything at all? The truth is, no one knows. Some physicists argue that reality itself is non-local, that space is an illusion, a mere byproduct of deeper, unseen connections. Others propose that hidden variables, unknown forces beneath the surface of physics, govern these interactions. But each explanation only replaces one paradox with another. The trap deepens. What if distance is a lie? What if space is not the vast, empty void we imagine, but an intricate web where every point touches every other? What if we are not looking out into the universe, but merely staring at different aspects of the same singular, entangled entity? And here is where the terror creeps in. If fundamental particles, electrons, photons, the very building blocks of reality, can be entangled, then what else is? What about your brain, your thoughts, your consciousness? Could your decisions, your emotions, be tethered to something unseen, something distant, something pulling invisible strings? There is no reason to believe entanglement is limited to the quantum scale. If atoms, molecules, even entire systems can become entangled, what if your very existence is bound to something or someone else? The implications stretch beyond physics, beyond philosophy, into something deeply unsettling. If you think a thought, does someone else, somewhere, think it too? If you feel an emotion, does it ripple across the fabric of reality, influencing something unseen? Consider this. What if you are entangled with something you have never met? A place you have never been? A mind you do not know exists? What if every action you take alters a hidden counterpart in the universe? And the final, most disturbing thought: if nothing is truly separate, if everything is entangled in ways we cannot comprehend, then are you truly alone? Imagine you are sitting in a room, staring at a machine with a single button. The machine is connected to a quantum particle, an unpredictable, unknowable entity that exists in a state of superposition until it is measured. If the particle spins one way, the machine remains silent. If it spins the other way, it activates a device that will instantly end your existence. You take a deep breath. You press the button. The machine clicks, and you are still here, alive, safe. You press it again. Another click. Still alive 100 times, 1,000. Each time, the machine makes its quantum decision. Yet no matter how many times you try, you survive. Others might observe from the outside and see you perish at random intervals, but from your own perspective, you never experience the moment of death. Instead, you always find yourself in a reality where you continue to exist. This is quantum immortality, a disturbing implication of the many worlds interpretation of quantum mechanics. The theory suggests that every time a quantum event occurs, reality splits. Every possible outcome is realized in a branching web of universes. In one version, the machine fires and you cease to exist, but in another, you remain alive. And because you can only perceive the reality in which you continue to exist, you are trapped in an endless loop of survival. It is a paradox that shatters the meaning of life and death. Think about what this truly implies. If every decision, every moment of chance, creates an infinite cascade of alternate realities, then what does it mean to be you? Are you just one version of an endless stream of selves, diverging with every breath? If consciousness only persists in realities where it survives, then does death even exist in any meaningful way? Now let's go further. If this paradox applies to you, it applies to everyone. There is always a version of reality where someone narrowly avoids disaster. Always a world where a fatal accident is miraculously averted. But here's the true horror. If you are bound to exist in a world where you never perceive your own death, does that mean you are trapped in an eternal prison of survival? As the universe collapses, as entropy grinds existence into dust, will you always find yourself in the last flickering moments of reality, unable to escape? Consider this. If death is just the absence of perception, and perception only exists in timelines where you survive, then you may already be living in a reality sculpted by quantum immortality. Every danger you have ever faced, every near miss, every inexplicable stroke of luck. What if they were not luck at all, but evidence that you are already moving through an endless chain of survival? And the final, most unsettling question: if death is an illusion and the self is endlessly fractured across infinite realities, then who are you right now? You are alone in a room, or at least you think you are. The silence is thick, the air unmoving. You reach for a coin in your pocket, hold it between your fingers, and prepare to flip it. But something feels off, a presence, not something you can see, not something you can hear, but something that changes everything. You flip the coin. It spins through the air, tumbling, caught between heads and tails, a blur of possibilities. But the moment you look at it, the moment you focus, your attention, reality makes a choice. The coin lands. One side up, definite, certain. Now ask yourself, was it always going to land this way? Or did your very act of observing force the universe to decide? This is the observer effect, an unsettling feature of quantum mechanics where the mere act of measurement changes reality itself. At the smallest scales of existence, particles exist in superposition, existing in multiple states at once, undefined, potential. But the moment they are observed, they collapse into a single outcome. The implication is disturbing. Reality does not take a definite form until something, someone, looks at it. Electrons do not have fixed locations. Photons do not have fixed paths. The entire universe, at its most fundamental level, remains fluid and uncertain until it is seen. And this raises a horrifying question. What does it mean to observe? If looking at something forces it into existence, then who or what is looking at you? Let's go deeper. Imagine an experiment. A beam of light is fired at a barrier with two slits. If no one measures which slit the light passes through, it behaves like a wave, spreading out, creating an interference pattern, existing in all possibilities at once. But if a detector is placed to observe the light's path, everything changes. The wave collapses. The interference disappears. The light behaves as if it had always been a particle, choosing a single, definite path. It's as if reality knows it is being watched. Which forces us to confront something terrifying. If observation alters reality, then does that mean reality is dependent on being observed? What happens in the places no one looks? Do they remain undefined, mere probabilities waiting for a gaze to solidify them? And then, the question you can't ignore. If reality needs an observer to exist, then before there were eyes to see, before there was life to perceive, before consciousness itself, was there anything at all? You step into a machine, cold metal, dim lights flickering in the control panel. A lever waits beneath your hand, trembling as if it already knows what you're about to do. You take a breath and pull it. The world twists. Time bends. The present disintegrates, unraveling like an old threadbare fabric. And when you open your eyes, you are no longer in your own time. You are in the past, A different era, a different world, a time before you were even born. You wander the streets, watching unfamiliar faces, breathing air that feels wrong. This is not where you belong. But then you see him, the man who will one day become your grandfather. He is young, unaware of the importance of his existence. And then a thought creeps in, a dark, forbidden thought. What if you were to stop him from meeting your grandmother? What if you were to erase the very moment that led to you? A moment of hesitation, a choice, a paradox. The grandfather paradox is one of the most haunting contradictions in the fabric of time travel. If you were to go back in time and prevent your own grandfather from having children, then you would never be born. But if you were never born, you could never have traveled back in time to interfere. This creates an impossible loop, a contradiction that defies logic. Which reality wins? Does time protect itself, preventing you from changing anything? Or does it fracture, splitting into infinite timelines, one where you were never born and another where you still exist? Let's go deeper. If the past can be altered, then reality itself is unstable. Every event, every action becomes fragile. If time does not follow a linear, unbreakable path, then cause and effect begin to collapse. And if you were never born, then who pulled the lever? Who stepped into the machine? Perhaps time resists change, correcting itself in ways we don't understand. Maybe the universe enforces consistency, subtly redirecting events to ensure that no paradox can ever truly occur. But what if it doesn't? What if paradoxes do not break reality, but instead rewrite it, reshaping the past, erasing the present, birthing a future that was never meant to exist? And the final, most terrifying question: if reality can be rewritten, if the past is not fixed, then how can you be sure that the world you remember was ever the real one at all? A book appears on your doorstep. No return address, no explanation. Just a book, old, worn, yet familiar. As you flip through its pages, your breath catches. It's filled with knowledge that shouldn't exist yet, equations not yet discovered, ideas that haven't been thought of, a blueprint for the future. Years pass. You study the book, memorize its every detail. The knowledge inside shapes your career, your discoveries. Eventually, you decide to publish it, sharing its insights with the world. The book becomes famous. It inspires generations. And then, one day, an old, worn copy of it is left on a doorstep. The same doorstep where you once found it. This is the Bootstrap Paradox, a loop in time where information, objects, or even people exist without ever having been created. The book was never written. It simply exists, passed endlessly through time, with no true origin. It has no beginning, no author, no point of creation, and yet it's real. Now take a step further. Imagine a composer hearing a mysterious melody in a dream. The next morning, he writes it down, perfect in every note. Years later, he finds an old recording of the same melody, one he wrote. The melody had no origin. No one truly composed it. It simply moved through time, looping endlessly. Where did it come from? The Bootstrap Paradox breaks everything we understand about cause and effect. It suggests that time is not a straight line, but a self-contained loop where events create themselves. A person can be their own ancestor. A message can be sent from the future to the past, only to be repeated in the future again. And then the question that lingers, the question you cannot escape. If information, objects, even identities can exist without creation, then what about you? What if you are part of a loop? What if your thoughts, your choices, your very existence are not your own, but something caught in a cycle, repeating endlessly? If something has no origin, no starting point, then was it ever truly real? You stand before a flickering candle, its flame swaying with the unseen currents of the air. It dances, fragile yet persistent, wavering between life and death. Now, imagine watching it closely, not just observing, but scrutinizing every moment, every flicker, every shift in the glow. And then something strange happens. The more you watch, the less it changes. The flame, which should be in constant motion, begins to freeze in place, resisting the natural pull of time itself. It's as if reality hesitates, as if the mere act of observing is locking it in a state of stillness. This is the quantum Zeno paradox, an eerie phenomenon in which constant observation prevents change. In the realm of quantum mechanics, unstable particles should decay over time, following natural laws. But if they are observed continuously, something unnatural happens. They refuse to decay. They remain suspended in time, trapped in a limbo between existence and dissolution. The very act of measurement alters their fate. Let's go deeper. Imagine you are falling, not metaphorically, physically, plummeting toward the earth. The seconds blur past. Gravity is absolute, unstoppable. But now, imagine that someone watches you with perfect, infinite attention. Their gaze, unwavering, tracking your every moment. The more they observe, the more reality hesitates. You do not hit the ground. You do not continue to fall. You become frozen in motion. This paradox suggests something deeply unsettling. Change itself may not be a fundamental part of reality, but something that must be allowed to happen. If no one observes an event, it unfolds naturally, governed by time. But if observed continuously, reality resists, hesitates, refuses to proceed. So now, ask yourself, what does this mean for your own existence? Are you moving through time, evolving, changing, because no one is watching too closely? And if someone or something were to observe you endlessly without pause, would you stop? Would you become trapped, unchanging, a thought frozen in time? And the most disturbing question, if reality is shaped by observation, then what happens when the universe itself begins to watch you? You are falling. The stars stretch and distort around you as you plummet toward an event horizon, a boundary beyond which nothing escapes. Light bends in ways it shouldn't. Time twists into something unrecognizable, and every instinct tells you that beyond this point, there is only oblivion, a black hole, the ultimate void, the great eraser of existence. As you cross the event horizon, something terrifying happens. The universe watches you vanish, but from the outside, you never really disappear. Instead, you appear frozen at the edge of the black hole, your image, stretched, distorted, fading into nothingness over an eternity. To the outside observer, you are still there, but to yourself, you are falling deeper, deeper into a place where space and time collapse, where the very laws of physics unravel. And then, you reach the singularity, the point of no return. Everything that enters a black hole is supposedly lost forever. It is crushed, erased, swallowed by an abyss where not even light can escape. But here lies the paradox. Where does the information go? Physics tells us that information cannot be destroyed. Every particle, every atom, every quantum state that ever existed must remain somewhere. It can transform, it can scatter, but it cannot simply cease to be. Yet, A black hole seems to defy this fundamental rule. It consumes matter, energy, and all the intricate details of existence, leaving behind only darkness. Does the information simply vanish? Some physicists believe the information is stored on the event horizon itself, encoded like a cosmic hologram, a two-dimensional surface containing the complete history of everything that has ever fallen in. If this is true, then reality as we know it is not three-dimensional, but a vast, projected illusion. Others propose that black holes do not truly destroy information, but scramble it beyond recognition, releasing it back into the universe through subtle quantum processes. But if the original state of matter can never be recovered, then is it truly the same information, or has reality been rewritten? And the most disturbing possibility, what if the information does vanish? What if black holes are not just cosmic traps, but something far worse? Loopholes in reality, places where the fundamental rules of existence fail? If information can be erased, if something can be truly lost with no trace, then what does that say about you? If the universe allows for oblivion, true, irreversible erasure, then how can you be certain that you are not already fading into it? Imagine you are standing before a vast cosmic machine, one that does not just measure reality, it decides it. A single particle is fired toward a barrier with two slits, and you are given a choice. You can measure which slit it passes through, or you can let it travel undisturbed. But here's where it gets strange. If you observe the particle's path, it behaves like a tiny bullet, passing cleanly through one slit or the other. But if you do not observe it, the particle acts as a wave, passing through both slits simultaneously, interfering with itself, creating a ghostly pattern of probability. It's as if reality does not commit to a single version of events until it is forced to. Now step deeper into the paradox. What if you delay your decision? What if you choose whether to measure the particle after it has already passed through the slits? Logic should dictate that the particle has already made its choice. It has either gone through one slit or both. The past should be fixed, but it isn't. Your delayed choice changes the past. If you decide to measure, the particle retroactively behaves as though it always passed through one slit. If you do not measure, it behaves as though it had always passed through both. The particle's history is rewritten. Reality, it seems, waits for your decision. But what does this mean? It suggests that the past is not set in stone. That time itself does not flow in one direction, but is instead fluid, shifting based on present observation. It suggests that the universe does not decide what is real until consciousness forces it to. And now, the most disturbing question. If the past can be rewritten, if observation determines what was real, then how do you know that your own past has not changed? What if every memory you hold, every event you believe to have happened, is simply the version of reality that your mind has observed into existence? And if you were to stop observing, if you were to close your eyes, to look away, would your past even exist at all? You wake up in a darkened room, a void of silence stretching infinitely around you. No walls, no ceiling, no floor, just emptiness. But the moment you think of something, a light, a doorway, a flicker of color, it appears. The world is not there until you observe it. Now, what if this is not just an illusion? What if this is the true nature of the universe? John Wheeler, one of the most provocative minds in physics, proposed something unsettling, that the universe does not exist in a definite state until it is observed. The act of looking, of measuring, of knowing is what forces reality to solidify from a mist of probabilities into something real. In other words, The universe is not a pre-existing stage upon which we act. It is a script that writes itself only when we read it. Let's take this further. Imagine a distant galaxy, billions of light years away. Light from that galaxy has been traveling toward Earth since before humans even existed. Yet, according to Wheeler's idea, that light does not take a definite path until we observe it. It means that by looking at a distant star today, we are determining its history, deciding its past in real time. Does this sound impossible? Perhaps. But experiments support it. Quantum mechanics has repeatedly shown that particles do not exist in a definite state until they are measured. Wheeler took this one step further, suggesting that not only do small particles behave this way, but reality itself, that the universe, from the smallest atom to the grandest galaxy, is a participatory act. It waits for a witness. Now, let the implications sink in. If observation creates reality, then what was the universe before anyone looked at it? Did it exist at all? If no one had ever been born, if no conscious mind had ever evolved, would there even be a universe to speak of? Or did the cosmos remain a ghostly haze of probabilities until the first observer opened their eyes, collapsing the fog of nothingness into something real? And now, the question that lingers like a shadow at the edge of thought. If the universe only becomes real when it is observed, then who or what was the first observer? Did reality create consciousness, or did consciousness create reality? And more disturbingly, if no one were left to observe the universe, would it simply vanish? Imagine for a moment that everything you know, your memories, your body, the entire universe, was an illusion. Not in a metaphorical sense, but in a disturbingly literal way. What if you were not a person, not a product of billions of years, of evolution, not the result of a cosmic history stretching back to the Big Bang? What if you were just a thought, a self-aware fluctuation that appeared randomly in an otherwise empty void? This is the Boltzmann brain paradox, a deeply unsettling idea that challenges the very nature of reality. According to thermodynamics, the universe is constantly moving toward disorder, but in an infinite amount of time, even the most improbable events must eventually happen. A tornado could assemble a fully functional car from scattered debris. A shattered vase could spontaneously reassemble itself. And, most disturbingly, consciousness. You could emerge from pure randomness, floating in the darkness of an empty cosmos. A brain complete with memories of a life that never happened. Let's take this further. If the universe is infinite and chaotic, then the spontaneous formation of a single self-aware mind, a Boltzmann brain, is actually more probable than the emergence of an entire ordered universe like ours. It would take far fewer random fluctuations to create a temporary, isolated mind than to generate an entire cosmos filled with galaxies, stars, and planets. Which leads to the most unsettling question. What are the odds that you are really a human, living in a stable, evolving universe, versus the odds that you are merely a fleeting conscious blip in the vacuum of nothingness? Think about it. If a Boltzmann brain can form anywhere, at any time, then statistically speaking, it is far more likely that you are just one of them. An ephemeral thought with artificial memories, destined to vanish as quickly as you appeared. How can you ever know that your past is real? What if the moment you stop thinking about the world, it ceases to exist? What if you will dissolve in the next instant, never having truly existed at all? And now, the most terrifying realization. If Boltzmann brains are real, then the vast universe you believe in, the people you love, the history you trust, might be nothing more than the echo of a mind that was never supposed to exist. You stare at the cat, or rather, you think you do, but something is wrong. The cat's body is here, solid, real, undeniable, and yet, its grin hangs elsewhere, detached, suspended in empty space, mocking you. It watches without watching, existing without existing, a paradoxical illusion, except in the quantum world, this is no illusion at all. Welcome to the Quantum Cheshire Cat paradox, where an object and its property, its defining characteristic, can be separated, as if reality itself can be split apart, defying the fundamental laws of identity. Imagine a world where a spinning top is here, but its spin is somewhere else. A world where a bullet is fired, but its velocity is detached from its trajectory. A world where a cat can be seen, yet its essence lingers in a different place altogether. This is not fantasy. This is physics. At its core, the Quantum Cheshire Cat paradox emerges from the strange mechanics of quantum measurement. When an object, such as a photon or an electron, is subjected to a particular type of quantum experiment, it can behave as if its properties have been stripped away from its physical form. The object moves through one path, while its defining characteristic, its charge, spin, or polarization, travels through another. It is as if reality has been split in two, one half ghosting away from the other, leaving behind an empty shell of existence. You might wonder, how can something be separated from itself? In the classical world, this is impossible. An object's properties, its weight, its position, its movement, are intrinsic. They belong to the object, inseparable from what it is. A spinning wheel must carry its own rotation. A walking person, he must take their own footsteps. And yet, in the quantum world, nature plays by a different set of rules. Imagine you are watching a stream split into two branches. A fish swims through one branch. But when you try to measure it, you find it's swimming. Motion, the very act of movement, is passing through the other branch. You see the creature's shape, but its essence is elsewhere. This is not a trick of perspective. It is an experimentally verified phenomenon. Scientists have demonstrated that neutrons, when sent through a specialized interferometer, can be split from their spin, their defining quantum property. The neutron goes one way, its spin goes another. It is an eerie thought, isn't it? That identity is not absolute. That reality can be sliced apart, leaving behind hollow remains. But consider the deeper horror lurking beneath. If objects can be split from their own properties, then what of you? What defines you at this moment? Your body is here. But what about your consciousness, your thoughts, your sense of self? If quantum properties can be severed from the particles that carry them, then what prevents you from being split? Your awareness drifting elsewhere while your physical shell remains behind. What if, as you listen to this, some part of you has already detached, floating unseen, just beyond your reach? And if that is the case, who is really thinking these thoughts right now? Close your eyes. Imagine standing before a machine, one that determines your fate with the cold indifference of the universe itself. A quantum trigger is set. It will fire with a 50% probability, and if it does, the machine will end. You instantly, painlessly. If it does not, you will live. Now imagine pressing the button. Click. You open your eyes. You are still here. You press it again. Click. Still here. Again. Click. Again. Click. No matter how many times you test fate, you always wake up on the other side, untouched, immortal. But how? Welcome to the Quantum Immortality Paradox, a disturbing implication of the many worlds interpretation of quantum mechanics. Every time you press the button, the universe splits. In some versions of reality, the machine fires and you cease to exist. In others, it does not, and you continue. From an outsider's perspective, you are simply playing with an impossible risk. Eventually, the machine must win. But from your own perspective, from the conscious thread of experience you call you, the outcome is different. You can never experience your own death. You will always find yourself in the branch where you survive. But this is where the horror begins. If you are truly trapped in a self-selecting chain of survival, what does this mean for suffering? You may survive every fatal accident, every disease, every catastrophe, but at what cost? If the only versions of you that persist are the ones that have endured every disaster, then perhaps you are not destined for endless life, but for endless survival, forever moving forward into branches where you continue, regardless of the pain, regardless of the decay. A universe where you always wake up, but never escape. Look around you. How many times should you have perished already? The near misses, the close calls, the moments when you felt the icy touch of fate but somehow, inexplicably continued. What if every version of you that did not survive has already faded into the void? And you, the only version that remains, are trapped in the longest, unbroken sequence of survival. And if you are truly unkillable in your own frame of reference, if you are condemned to persist in whatever fractured reality still allows you to exist, then tell me, how does your story end? Does it ever? 3 pigeons, 2 boxes. A simple question. If you place 3 pigeons into 2 boxes, at least one box must contain at least 2 pigeons, right? This is common sense, a fundamental rule of classical logic. It is so obvious that it barely needs to be stated. But in the quantum world, even the simplest truths collapse into contradiction. Welcome to the quantum pigeonhole principle, where you can place 3 quantum particles into 2 boxes, and somehow, impossibly, no 2 particles ever share a box. It is a paradox so bizarre, so unnatural, that it threatens the very concept of grouping, categorization, and even existence itself. Imagine pulling 3 objects from your pocket and placing them into 2 containers. When you check, each container reveals a single object, and yet all 3 objects have somehow been placed. Where is the missing overlap? Where is the logical consistency? You check again. Same result. You check a 3rd time, and a 4th, and still the contradiction remains, mocking the very foundation of your intuition. This is not a trick. It is not an illusion. It is an experimentally valid phenomenon, one that physicists have demonstrated using photons and quantum interference. In a carefully designed quantum system, particles can avoid each other in a way that defies logic, behaving as though they are actively conspiring to never occupy the same space, even when forced into a limited number of options. But how can 3 objects be distributed into 2 spaces without any 2 sharing a space? The answer lies in the wave-like nature of quantum entities. Unlike classical objects, quantum particles do not exist as fixed, well-defined entities. They exist as probabilities, superpositions, smears of possibility stretched across space. And when you attempt to force them into distinct categories, into separate boxes, their quantum nature resists. They interfere with themselves, creating a system in which the expected overlap simply vanishes. Do you feel the logical discomfort setting in? Do you sense the quiet terror beneath this paradox? Because if objects as fundamental as particles can defy grouping, can refuse to be categorized, what does that say about the nature of identity? About your identity, you think you are one person, a single, coherent being. But what if, when examined under the quantum lens, you are something else? A shifting, undefined blur of possibility, a superposition of multiple states, resisting classification. And if the universe itself refuses to allow simple grouping, then what happens when you try to categorize your own thoughts, your memories, your sense of self? Are you truly one person? Or are you merely an illusion of consistency, a fragmented wave flickering between states, never fully existing in one place? If three things cannot be placed into two without contradiction, then tell me, where are you right now? Imagine a shadow that only appears when you turn away. A ghost that only exists when you are not looking. A predator that feeds on your awareness, shaping itself in response to your gaze. This is not the stuff of nightmares. This is the reality of quantum mechanics. A universe where particles change their nature based on whether they are being watched. A reality that remains undefined, unresolved, until it is observed. Physicists call it the observer effect. But in its most chilling form, it manifests as something even more disturbing, something akin to a quantum vampire, a phenomenon that feeds on your act of measurement, twisting reality in the process. Consider the classic double-slit experiment. Fire individual photons at a barrier with two slits, and they behave like waves, spreading out and interfering with themselves, creating a pattern of alternating dark and light bands on a screen. But introduce a detector to see which slit the photon passes through, and the wave collapses. The interference vanishes. The photon suddenly behaves like a particle instead, as if it knows it is being watched. But now, imagine taking this a step further. Imagine you delay your observation, waiting until the photon has already passed the slits before deciding whether to check which path it took. In the delayed choice quantum eraser, even after the photon has seemingly made its decision, your later choice to measure or ignore its path reaches backward in time, altering the past. The interference pattern disappears or reappears, dictated by a decision made after the fact. Do you understand what this means? Your present choices can rewrite past reality. Events that should have already happened remain unsettled, dangling in a fragile quantum limbo until you make an observation. The past itself does not exist as a fixed, solid history. It exists in a superposition, waiting to be solidified by your awareness. Now, let that sink in. Your memories, your history, the reality you think you've lived. What if it is just like the photon's path, unwritten, uncertain, only truly real when you recall it? Perhaps there are pasts that never happened, pasts that existed only in potential until you observed them into reality. Perhaps the past is not something that was, but something that is, still becoming, still waiting for your mind to bring it into being. And if you refuse to look, if you refuse to observe, then tell me, does the past even exist at all? What if time wasn't what you thought it was? What if it didn't flow, didn't move, didn't carry you forward, but instead shattered into an infinite sequence of frozen moments, each one still, motionless, eternally trapped in its own existence? Look at your hand, move your fingers. It feels smooth, continuous, but that's only an illusion. In reality, your motion is stitched together from discrete, indivisible slivers of time, each moment separated from the next by the smallest possible unit of time, the Planck time, an interval so short that billions of them could pass in the blink of an eye, and you would never notice. But now imagine this. What if you were trapped within just one of those moments? Imagine for an instant that time does not progress. That, instead, You are locked inside a single frozen frame of existence. No past, no future. Just this thought, this awareness, this exact moment, stretching forever with no way out. You may think, that's impossible. Time must move forward. But what proof do you have? All you ever experience is now. The past is only a memory. The future is only an expectation. But the present is all that is ever real. What if consciousness itself does not move through time, but is simply a series of disconnected, frozen snapshots, each one believing it is flowing forward, even though it never truly moves? Perhaps you are already trapped. Perhaps you have always been trapped. What if your sense of motion, of change, of continuity is nothing but an illusion, a trick played by the mind as it stitches still frames together like a broken film reel? And if that is true, if you are nothing but a prisoner of a frozen moment, then answer this. How can you ever be sure that time will move again? Close your eyes. Imagine a world that only exists when you look at it. The moment you turn away, it vanishes, ceases to be anything more than a formless probability cloud. Now, open your eyes again. The world snaps back into focus, as if it had always been there. But had it? This is the disturbing implication of the quantum observer effect. The idea that reality, at its most fundamental level, does not take a definite form until it is measured, until it is observed. Particles do not simply exist in a fixed state. They remain in a limbo of possibilities until the moment they are seen, at which point they decide what they are. But this leads to a horrifying question. What happens to the universe when no one is watching? If observation collapses reality into a definite state, then what about the spaces beyond your perception? The room behind you, the stars above, the atoms in your very body. Are they truly there when you are not looking? Or do they flicker in and out of existence, waiting, lurking for the moment they are seen? Imagine waking up in a pitch-black void. No sound, no light, just a suffocating absence of everything. You reach out, searching for something, anything solid, and the moment your fingers expect to feel something, it appears, a surface forming just as your mind anticipates it. You move forward. More of the world emerges around you, assembling itself piece by piece, responding not to physical law, but to the simple act of expectation. Now consider this. How is that different from the reality you know? If everything around you depends on observation, then what if your entire life has been nothing but a hallucination shaped by expectation? What if your past only exists because you remember it? What if the future only takes form because you anticipate it? What if, when you finally close your eyes for the last time, the world does not continue without you, but instead ceases to exist entirely? And if that is true, then tell me, who or what is watching you? You exist in a world of 3 spatial dimensions: length, width, height. Everything you know, everything you've ever touched or seen, fits neatly within this framework. But what if I told you that this is nothing more than a shadow of a far greater reality, one that lurks just beyond your perception, influencing you in ways you can never comprehend? Mathematics demands the existence of higher dimensions, realms that fold over our own, guiding the fundamental forces of the universe. Theoretical physics suggests that beyond our familiar 3-dimensional space lies a 4th spatial dimension, a 5th, perhaps even more, each one stacked over reality like unseen layers of a cosmic blueprint. You cannot see them. You cannot reach them. But they are there, pressing in on your world like an invisible weight. Imagine a two-dimensional being, a flat creature living on the surface of a sheet of paper. To it, up does not exist. It cannot conceive of depth. But you, as a three-dimensional observer, can reach into its world effortlessly, moving through barriers that to it would seem impenetrable. You could watch this being without ever revealing yourself, influencing its reality in ways it could never understand. Now, reverse the roles. What if you are the flat creature? What if something beyond your three-dimensional world is reaching in, manipulating, watching, changing things in ways you will never notice? What if déjà vu, ghostly figures, impossible coincidences, all the things that make you feel like reality is slightly off, are nothing more than glimpses of a higher dimensional force nudging your world? You think you are free, that you move on your own, that your choices are your own. But what if your reality is nothing more than a projection, your very existence shaped by a dimension you can never access? What if the answers to everything, the force behind the universe, behind time itself, are hiding just beyond your reach? And if that's true, then ask yourself, are you being watched? You drop a glass, it shatters into 1,000 fragments. The event is irreversible, at least that's what your mind insists. Cause precedes effect. The past creates the future. That is the natural order of things. But what if time does not flow the way you think it does? In the bizarre world of quantum mechanics, there are experiments suggesting that the future can dictate the past, that an action taken now can retroactively change what has already happened. This is the unsettling implication of time-reversed causality, a concept that shatters your deepest assumptions about reality. Consider the famous delayed choice experiment. A particle moving through a system behaves differently depending on whether it is measured. But here's where it gets eerie. The decision to measure the particle can be made after it has already passed through the system. Yet this late decision somehow reaches backward in time, altering the particle's past behavior. It is as if reality waits, undecided, until a conscious observer forces it to make a retroactive choice. Now, apply this principle to your own life. If future choices can influence the past, then how much of what you remember was truly set in stone? Could certain decisions you will make in the future be actively rewriting your past experiences, reshaping your memories, reconstructing the very foundation of your existence without you realizing it? What if history itself is fluid, bending under the weight of yet-to-be-made choices? What if your regrets, your mistakes, your defining moments were never truly fixed, but instead ripple forward and backward through time, constantly in flux? And if the past can be rewritten, then ask yourself, how do you know the life you remember is the one that actually happened? You go about your day believing the universe is stable. The sun rises, the earth turns, reality persists. But what if this is all an illusion? What if, at any moment, without warning, the very fabric of existence could be rewritten, annihilating everything you know in an instant? This is the terrifying possibility of vacuum decay, a concept in quantum field theory that suggests our universe may not be in its true lowest energy state. Instead, we could be trapped in a false vacuum, a temporary, unstable version of reality just waiting to collapse. And when it does, the change would propagate at the speed of light, consuming everything in an inescapable wave of destruction. There would be no warning, no sign of impending doom. One moment, everything would seem normal. The next, the very laws of physics would shift into something unrecognizable, and the universe you know would cease to exist. And here's the truly horrifying part. This process may have already begun. Somewhere, in the cold void of space, vacuum decay could have been triggered. an invisible wall of total annihilation racing toward us at this very moment. Since it moves at the speed of light, we wouldn't see it coming. There would be no escape. By the time you perceive it, you will have already been erased. Now, consider the implications. If reality can end without warning, does anything you do truly matter? Does meaning exist in a universe where everything is one quantum fluctuation, away from non-existence? Or is your life nothing more than a fragile illusion waiting to be rewritten in an instant? You believe in the reality around you, the ground beneath your feet, the air you breathe, the people you love. All of it feels real, tangible, unquestionable. But what if I told you that none of it exists? That everything you experience, everything you remember, might be nothing more than a fleeting hallucination, a momentary flicker in an infinite void. This is the nightmare of the Boltzmann brain paradox, a horrifying thought experiment that emerges from statistical mechanics and quantum theory. It suggests that in an infinite universe, the random fluctuations of particles will eventually produce self-aware entities, floating minds that pop into existence, fully formed, with detailed memories of lives they never actually lived. Think about that. Your entire life, your childhood, your past, the world you think you've known, could be nothing more than a fabrication, spontaneously generated in the last instant. You might not be a person in a vast, evolving universe. You might be a disembodied thought, drifting in a cold, eternal void, created by pure chance and destined to dissolve just as quickly. And the worst part? If Boltzmann brains are more statistically likely to exist than full-fledged universes, then it is far more probable that you are one of them. The structured, lawful cosmos you believe in, the stars, the galaxies, the endless march of time, might not be real at all. The true nature of existence might be chaos, with rare moments of ordered thought flickering in and out of the abyss. So, tell me, how do you know that the world around you isn't just a brief, meaningless illusion, one that will blink out of existence before you even finish your next thought? Imagine you are in a sealed laboratory, conducting a simple quantum experiment, measuring a photon's polarization. Until you check, the photon exists in a superposition of states, neither definitively horizontal nor vertical. You perform the measurement, collapse the wave function, and record the result. Now, outside the lab, your friend Wigner waits. He has no access to your measurement, no knowledge of what you saw. From his perspective, you, along with the photon, still exist. In a quantum superposition, to him, your conscious experience of the measurement is not yet real. So who is correct? Inside the lab, reality has resolved itself. Outside the lab, Wigner sees an unresolved world, where you, the photon, and the entire lab exist as an entangled wave of probabilities. The contradiction is unbearable. Two equally valid versions of reality exist at the same time. This is Wigner's friend paradox, a thought experiment that shatters the conventional notion of objective reality. If quantum mechanics applies universally, then Wigner is right. Until he looks inside, your consciousness remains undefined. But that means your own experience of reality is nothing more than an illusion of certainty, dependent on someone else's observation. It gets worse. If Wigner himself were inside a larger sealed lab, his fate would be unknowable to a greater observer. And if reality is defined by observation, who, if anyone, collapses the ultimate wave function of the universe? What if no one does? Take a deep breath. Now, picture a long, dark hallway stretching before you. At the far end, a single slit in the wall allows a thin beam of light to pass through. You observe the light forming a simple, predictable pattern on the screen behind it. Nothing strange, nothing unsettling. But now, imagine another slit opening beside the first one. Logic tells you that the light will split into two beams, forming two distinct patterns. It makes sense. That's how the world works, cause and effect, predictable and orderly. Except that's not what happens. Instead of two patterns, the light forms a series of bright and dark fringes, an interference pattern, as if the light were a wave, passing through both slits simultaneously, spreading, rippling, interfering with itself. But light isn't just a wave, it's also made of particles, tiny, photons. So you decide to fire them one at a time, single photons passing through the slits, eliminating any possibility of them interacting with each other. Yet, the interference pattern still appears. You don't understand. How can a single photon pass through both slits at once? How can something exist in two places simultaneously? It makes no sense. So, you take the next logical step. You place a detector at the slits, watching to see which slit each photon goes through. And that's when everything collapses. The moment you observe the photon, the interference pattern disappears. Suddenly the photon behaves like a particle again, passing through one slit or the other, as if it knew it was being watched. Your act of measurement has forced the photon to choose. Think about that. Your mere observation has altered reality. The photon is not just an objective thing moving through space. Its existence is somehow tied to your awareness of it. And this is where the nightmare begins. If a simple photon refuses to take shape until it is observed, what about the rest of reality? What about the chair you're sitting on, the screen in front of you, the air in the room? Are these things solid, independent structures, or do they exist in a haze of probabilities, waiting to be pinned down by your consciousness? And if observation creates reality, then whose observation created you? Are you watching the universe, or is the universe watching you? You wake up. You see the ceiling above you. Feel the weight of the blanket against your skin. Hear the distant hum of a world stirring beyond your walls. Everything feels real. Everything appears solid, tangible, unquestionable. But how do you know, not just assume, not just trust your senses? How do you truly know that what you are experiencing is real? Take a moment. Look at your hands. Feel the texture of your skin, the slight warmth radiating from your fingertips. Now consider this. Every sight you see, every sound you hear, every sensation you feel, all of it is nothing more than electrical signals interpreted by your brain. And if your brain is just processing signals, then how do you know the source of those signals is real? This is the simulation hypothesis, the idea that your entire reality, everything you have ever known, every experience, every thought, might not be physical at all, but instead the result of an intricate artificial construct. A simulation at first, it sounds absurd. How could the world around you be fake? How could your life be nothing more than a construct of information? But the more you pull at the thread, the more unsettling the possibility becomes. Consider this. If technology continues to advance, we will one day have the ability to create hyper-realistic simulations, worlds so detailed and convincing that their inhabitants, artificial minds, would be unable to distinguish their reality from ours. Now, think about probability. If civilizations are capable of creating simulations, and they continue to do so, then for every real universe, there could be billions, perhaps trillions, of simulated ones. Which means the odds of you living in the one original base reality are astronomically low. And if you are in a simulation, then the very fabric of your world is not bound by natural law. The rules you assume to be fundamental, gravity, time, space, might not be universal truths, but rather programmed constraints. Glitches and inconsistencies might occasionally seep through, moments where reality bends in ways it shouldn't. Déjà vu, coincidences too perfect to ignore. Bizarre quantum behaviors where particles exist and do not exist at the same time. What's more, every simulation must have a purpose. Are you being watched? Studied? Is your existence merely an experiment? A test? Or are you the only real consciousness in an otherwise artificial world? And if this is a simulation, who or what is running it? Is it a post-human civilization, simulating its ancient past? Is it an alien intelligence recreating possible versions of existence? Or is it something beyond our comprehension, a force so advanced that it generated this reality as effortlessly as we create digital landscapes in a game? More importantly, can you escape? Or are you trapped here, endlessly looping, living the same programmed existence over and over, never realizing that none of it was ever real to begin with? Imagine you are holding two identical coins, each resting in the palm of your hands. You decide to separate them, placing one in a locked box on the farthest end of the universe while keeping the other with you. Now, the moment of truth. You flip your coin and it lands on heads. At that exact instant, without any delay, without even the passing of a single second, the coin in the distant box instantly flips to tails. No signal was sent. No information was transferred across space. And yet, as if reality itself had conspired in secret, the outcome was decided the moment you observed your own coin. This is the EPR Paradox, a mind-shattering problem that Albert Einstein, Boris Podolsky, and Nathan Rosen formulated in 1935 to highlight what they believed was a fatal flaw in quantum mechanics. It challenges the very nature of reality, forcing us to confront a terrifying possibility: that particles, separated by vast distances, can somehow be deeply, inescapably connected, as if they share a hidden thread woven into the fabric of the universe itself. But what does this actually mean? Let's break it down. At the quantum level, particles don't behave like solid objects. They exist in superposition, a ghostly state where they are both here and there, both spinning up and spinning down, existing in multiple states at once until something observes them. It is only when an observer intervenes that the particle is forced to choose a single reality, collapsing into a definite state. Now take two particles, born together, entangled at the very moment of their creation. Even if you separate them to opposite ends of the universe, something disturbing happens. The instant you measure one particle and determine its state, the other particle, regardless of the distance, instantly takes on the corresponding state. This should be impossible. Nothing, not even light itself, can travel faster than the speed of causality. Yet these entangled particles defy that rule, as if they are whispering to each other through a channel that exists outside of space and time. This is where the true horror sets in. If the universe has an upper speed limit, the speed of light, then this phenomenon suggests that entangled particles are communicating through something beyond the fabric of reality we understand. Are they connected by an unseen dimension, a hidden layer of the universe that bypasses space itself? Or is reality far stranger than we could have ever imagined? Einstein was deeply disturbed by this, famously calling it spooky action at a distance. He refused to accept that two particles could affect each other instantaneously across vast distances without some kind of hidden mechanism at play. He argued that there must be hidden variables, unseen information that determined the outcomes of quantum events in advance, making them appear random when, in fact, they were predetermined. But quantum mechanics had a different answer, one that shattered Einstein's belief in an objective, deterministic universe. In 1964, physicist John Bell devised an experiment to test whether these hidden variables truly existed. The results: quantum entanglement is real, and there are no hidden variables controlling it. The universe does not secretly operate on classical rules behind the curtain. The particles are truly connected in a way that defies space and time, and that realization forces us to ask, what does this say about reality itself? Is the universe truly local, with events bound to the constraints of space? Or are we living in a reality where distance is an illusion, and everything, every particle, every thought, every action is part of a singular, inseparable whole? Could it be that the fabric of the universe is not stitched together by space, but by information itself, a web of connections that we can't perceive, but one that dictates reality from behind the scenes? And if quantum mechanics is correct, if entanglement is real, then what else is connected in ways we cannot yet understand? Are we entangled? Are our thoughts, our choices, our very consciousness woven into a deeper reality, bound to unseen forces beyond our control? And if so, then who or what is observing us, collapsing our existence into reality? Imagine standing at a crossroads, faced with a simple choice, left or right. You hesitate, considering your options. Then, after a moment of thought, you step to the right, a simple decision. One path taken, the other abandoned. Or so you think. What if, at that very moment, reality itself split in two? In one universe, you turned right. But in another, just as real, just as vivid, just as conscious, you turned left. And in that world, your life unfolds down an entirely different path, leading to consequences you will never see, choices you will never make, but a version of you will. This is the many worlds interpretation, one of the most unsettling ideas ever conceived in quantum mechanics. It proposes that every quantum event, every decision, every possibility actually happens, but in different, parallel universes that branch off from one another like an infinite fractal maze. And if it's true, then your every action, every blink, every breath, every fleeting thought has already spawned countless other versions of reality. But where does this idea come from? It all begins with the quantum wave function, the mathematical entity that describes the state of a system in quantum mechanics. According to the standard view of physics, before a measurement is made, a particle doesn't exist in any one definite state. It exists in superposition, meaning it is in multiple states at once, like Schrödinger's infamous cat, both alive and dead inside its box. For decades, physicists believed that this strange, ghostly state collapsed into a single reality the moment an observer measured it. But in 1957, a young physicist named Hugh Everett III proposed something radical. What if, instead of forcing the universe to pick a single outcome, reality splits, creating a new universe for every possible result? A universe where the cat lives, a universe where the cat dies, a universe where you wake up 5 minutes earlier, universe where you never woke up at all. To Everett, this wasn't just a wild speculation, it was the most logical explanation for quantum mechanics. Why should the wave function suddenly collapse just because someone looked at it? Wouldn't it make more sense if both possibilities happened, just in separate realities? But the true horror of the many worlds interpretation isn't just that. Alternate versions of events exist. It's that every quantum interaction, on the smallest and largest scales, is constantly creating new branches of reality. The moment you decided to listen to this script, another version of you decided not to. Another version of you never even discovered this topic, Another version of you didn't survive the last year, and another version of you, maybe they are living a life you can barely imagine, one where a single small decision changed everything. But here's where things get even more disturbing. If many worlds is true, then there is no single you. You are not a fixed entity. You are not a singular consciousness moving through time. You are an infinite, ever-branching collection of identities, spreading across realities like a tree whose roots can never be traced back to a single point. So who or what are you, really? If you exist in countless variations across parallel worlds, then is the version of you experiencing this moment the real you, or just one of infinite echoes of a person that can never be fully defined? And if there is no collapse, if every possibility is played out in some alternate reality, then does free will even exist? You might believe you are making choices, deciding the course of your own future. But if every choice is realized in some other world, then do you ever truly decide anything at all? Or are you just an observer, watching one sliver of an infinite existence play out before you, while countless others unfold beyond your reach? And here's the final, most terrifying thought. If infinite versions of you exist, then somewhere, in some universe, there is a version of you who has figured out how to reach across realities. And if they could do it, if they could break through the barriers that separate us, would they try to contact you? Or are you already hearing their whispers in your dreams, in your thoughts, in those fleeting moments where you feel that something, some unseen force, is pulling at the edges of your reality? Imagine standing at the edge of a massive black hole, staring into the infinite abyss. The event horizon looms before you, a point of no return where even light itself is trapped. You take a deep breath, knowing that if you step forward, you will be lost forever. Every trace of your existence, every thought, every memory, every piece of information that made you who you are will be swallowed by the singularity, erased from the universe. Or will it? In the classical view of physics, information is never truly destroyed. The universe operates like an intricate puzzle where every piece fits together in a seamless pattern. Even when something is burned to ash, its fundamental information, the precise arrangement of atoms, the energy and momentum it carried, still exists, encoded in the smoke, heat, and scattered particles. Nothing is ever truly lost. But black holes challenge this fundamental rule. According to Einstein's general relativity, anything that crosses the event horizon of a black hole is gone forever. It falls inward, drawn by the unstoppable gravitational pull, until it reaches the singularity, a point of infinite density where the laws of physics break down. Once inside, no signal, no particle, no information can ever escape. This creates a paradox. If information is lost inside a black hole, then our entire understanding of physics collapses. The universe is supposed to be a closed system, where information is preserved. But black holes act like cosmic erasers, devouring knowledge and leaving only emptiness behind. Stephen Hawking himself helped expose the severity of this problem. In 1974, Hawking made a shocking discovery. Black holes are not entirely black. They emit a faint radiation, now known as Hawking radiation, slowly losing mass over time. Eventually, given enough time, a black hole will evaporate completely, leaving behind nothing. But if a black hole disappears, what happens to the information it consumed? Is it forever erased from reality? This is the heart of the information loss paradox. A contradiction so severe that it threatens the very foundation of quantum mechanics. One possibility is that black holes do destroy information, violating everything we know about physics. If true, this would mean that reality is not as deterministic as we believed. The past could be erased, cause and effect could be shattered, the universe could be fundamentally incomplete, with knowledge simply vanishing into oblivion. But another possibility is far stranger. Some physicists believe that the information isn't destroyed, but it isn't inside the black hole either. Instead, it might be stored on the event horizon itself, encoded in a thin, two-dimensional layer that acts like a cosmic ledger, recording everything that falls in. This idea leads to something even more unsettling: the holographic principle. If information can be stored on the surface of a black hole, then what if everything in the universe, every star, every planet, every moment of your life, is just a holographic projection of a deeper reality? What if everything you have ever experienced is not truly three-dimensional, but instead a shadow cast by some higher dimensional truth? And if black holes hold the key to preserving information, then could they also be hiding something else? Something beyond human understanding? Could black holes be cosmic vaults, locking away secrets we were never meant to uncover? Or worse, could they be gateways? If information can never be lost, then where does it go when a black hole evaporates? Does it re-emerge somewhere else? Does it escape into a parallel universe? And if someone, somewhere, has already figured out how to retrieve that lost information, what forbidden knowledge might they now possess? Perhaps, in the distant reaches of the cosmos, something is watching. Perhaps, something has been waiting. And if black holes are not just cosmic tombs, but cosmic mirrors, reflecting knowledge back into the fabric of reality, then maybe, just maybe, they are trying to tell us something we were never meant to know. You open your eyes. The room around you feels strangely still, like the universe is holding its breath. You reach for a glass of water on your desk, but before your fingers make contact, a thought crosses your mind. What if, until this very moment, the glass didn't truly exist? What if everything around you, the walls, the air, your very thoughts, only snap into existence the moment you observe them? This is the heart of the measurement problem, a paradox that shakes the very foundation of reality itself. It begins with quantum mechanics, the strange and unsettling framework that governs the smallest building blocks of the universe. Unlike the predictable world we see around us, the quantum world is not fixed. Particles exist in a blurry, ghost-like state, occupying all possible positions at once, a phenomenon known as superposition. Take an electron, for example. Before you observe it, it is everywhere and nowhere. It exists in all possible locations simultaneously, its reality smeared across space like an unfinished thought. But the moment you measure it, something inexplicable happens. The electron chooses. Instantly, it collapses from infinite possibilities into a single definite reality. It is as if, before you looked, the universe itself was undecided. This raises a disturbing question. Does reality exist independently of observation? Or is the universe waiting to be seen before it takes form? The infamous Double-Slit Experiment exposed this mystery in the most chilling way. Scientists fired tiny particles, like electrons, at a barrier with two slits. If electrons were simply tiny bits of matter, they should pass through one slit or the other, forming two distinct lines on a screen behind. But instead, they formed an interference pattern, a wave-like pattern suggesting that each electron passed through both slits at once, interfering with itself. It was as if the electron wasn't a single particle, but an infinite cloud of possibilities, a wave existing in multiple states simultaneously. Then came the unsettling twist. Scientists placed a detector at the slits, trying to observe which path each electron actually took. And the moment they did, the interference pattern disappeared. The electron no longer behaved like a wave of possibilities. It chose a single path. Observation itself changed reality. It was as if the universe had adjusted itself in response to being watched. This suggests something almost too eerie to comprehend. Consciousness may be woven into the fabric of reality itself. Does the act of observing something force the universe to decide its fate? And if so, what does that say about the nature of existence before it is observed? Was the moon there before anyone looked at it? Was the universe real before the first conscious being opened its eyes? Physicists have wrestled with this question for decades. Some propose that the wave function, the equation describing these infinite possibilities, is merely mathematical, a tool for calculation, but not a reflection of reality. But others believe something far stranger, that reality is fundamentally incomplete without observation, that nothing truly exists in a definite state until it is measured. Which brings us to an even darker implication. If reality only solidifies when observed, then what happens when you stop looking? What happens to the things behind you, beyond your field of vision, in the dark corners of the universe where no conscious being has ever turned its gaze? Do they remain real, or do they dissolve back into nothingness, waiting for a mind to summon them into existence? And if this is true, who or what was the first observer? Did the universe begin as an infinite cloud of possibilities, only crystallizing into existence when the first consciousness emerged? Or is there something watching, something beyond human perception, ensuring that reality remains intact even when we look away? If a tree falls in a forest and no one is around to hear it, does it make a sound, or does it never fall at all? The night sky, a canvas of darkness, punctuated by the cold glow of distant stars. A sight so familiar, so deceptively simple, that few ever stop to question it. But think about it for a moment. In an infinite universe, filled with an uncountable number of stars stretching out in all directions, shouldn't the night sky be ablaze with endless light? Shouldn't the darkness itself be impossible? This is Olbers Paradox, a question that lingers like a crack in our perception of reality. If the universe is infinite and filled with stars, then every line of sight should eventually strike the surface of a distant star. No matter where you look, your vision should be overwhelmed by the collective brilliance of the cosmos. And yet, the night remains black, an abyss, empty yet full, staring back at you. This isn't a trivial curiosity. It is a contradiction buried in the very fabric of existence. Because if the universe is truly infinite and eternal, then every speck of space should be burning with the relentless fury of stellar fire. The fact that it doesn't suggest something is terribly wrong with our assumptions about the cosmos. Either the universe is not infinite, or the stars are not eternal. And in that uncertainty, the illusion of cosmic permanence begins to fracture. For centuries, this paradox was ignored. The darkness of the night sky was taken for granted, an unquestioned feature of existence. But when minds finally turned toward it, the implications became disturbing. Could it mean that the universe had a beginning? That there was a time before stars? That we exist in a fleeting moment between oblivions? One explanation suggests that light, despite its relentless speed, does not have eternity to fill the void. That the universe had a starting point, a birth in fire, in expansion, in chaos. A moment when nothingness ruptured into being, and the stars began their long, slow burn. But if that's true, then what came before? Was there ever truly nothing? Or was there something else, something hidden, something erased. Another possibility lurks in the nature of light itself. The farther a star is, the longer its light must travel. And in an expanding universe, that light stretches, its energy drained into lower frequencies, until it fades into invisibility. The darkness we see is not an absence of stars, but the hushed echoes of their dying light, smeared across the cosmos into wavelengths beyond perception. But what if the truth is more unsettling? What if the darkness isn't merely an illusion of physics, but a consequence of something deeper? What if light itself is being devoured before it reaches us? What if the stars that should fill our sky have been extinguished by forces unseen? Forces older than time, lurking in the black void between galaxies. You see, when you stare into the night, you assume that darkness is just emptiness. But what if it isn't? What if the void is filled with something beyond comprehension? Something that light cannot escape? Something that feeds on it? Perhaps the night is dark not because the stars are absent, but because they are being silenced, one by one. And as you gaze into the abyss, you might wonder, how long before the last light vanishes? Before the darkness is all that remains? And if that moment comes, if the stars flicker out one by one, swallowed by an unseen force, will you even realize it before it's too late? Imagine a universe so far into the future that it no longer resembles the one you know. There are no stars, no planets, no galaxies, just an endless expanse of cold, empty space. The last flickering embers of existence have long since faded, and all that remains is a uniform void where nothing happens. No heat, no movement, no change. This is the terrifying fate dictated by the laws of thermodynamics. The universe is not just dying, it is fated to cease in an eternal stillness. But something about this feels wrong. You live in a universe of constant motion, of shifting energy, of birth and decay. And yet, the laws governing reality tell us that this must all eventually halt, that every fluctuation, every spark of heat will spread so evenly across the cosmos that no work can be done, no processes can unfold. Entropy, the relentless force of disorder, will win. But if entropy always increases, then why did the universe ever exist in a low entropy state to begin with? Why wasn't it born in the same still, lifeless equilibrium that it is doomed to become? If disorder is the natural state of all things, why was there ever order in the first place? You feel it now, the creeping dread of the heat-death paradox. You were never meant to question this. The laws of physics are supposed to be absolute. But this is a contradiction hidden in the heart of reality. We are told that the universe is running out of usable energy. The second law of thermodynamics demands it, and yet there was a time when energy was incredibly concentrated, when galaxies ignited from colossal explosions, when matter coalesced into the intricate patterns that gave birth to life. How could such an ordered system emerge from a principle that insists order must always decay? The deeper you look, the stranger it becomes. What if this has all happened before? Some theories suggest that the universe might undergo cycles of death and rebirth, collapsing and exploding again and again for eternity. But even this does not solve the paradox, because with each cycle, entropy should accumulate, making each new universe more chaotic than the last. There is no escape from disorder. Or perhaps there was never a beginning at all. Some physicists entertain the idea that the universe may be infinite in time, stretching backward forever. But this leads to an even greater nightmare. If the universe has existed for an infinite amount of time, then heat death should have already happened. There has been more than enough time for entropy to do its work, for every star to burn out, for every black hole to evaporate into cold nothingness. And yet, you are here, conscious, alive, staring into the abyss of a paradox that should not exist. If heat death is inevitable, if it is the fate of all things, then why has it not already claimed reality? What force, what hidden law has postponed? The end or worse? What if it has already happened, and you are just a fleeting dream in the final dying embers of a universe that has long since ceased to be? You have heard of black holes, the cosmic abysses where gravity is so overwhelming that nothing, not even light, can escape. A black hole is an object that swallows everything, reducing matter, energy, and even information to an unknowable fate beyond the event horizon. But what if there was another kind of singularity? Not one that devours reality, but one that vomits it out. This is the enigma of the white hole, the theoretical mirror image of a black hole. Unlike its darker counterpart, a white hole does not consume anything. Instead, it expels everything, spewing out matter and energy while refusing to allow anything to enter. It is an object that defies intuition, an entity that seems to violate the very nature of space-time. And yet, some physicists suspect that white holes might not just be theoretical. They could be lurking somewhere in the cosmos, hidden in plain sight. But the question gnaws at you. If white holes exist, where do they get their energy from? Black hole swallows matter, crushing it beyond recognition. But a white hole would need an endless source of energy to constantly emit radiation and particles without consuming anything in return. This is not just unusual, it is physically absurd. No known mechanism allows for an object that radiates indefinitely without depleting its source. And yet, the mathematics of general relativity suggest that if black holes exist, white holes should too. But this is only the beginning of the nightmare. Some theories propose that black holes and white holes are not separate entities at all, but two ends of the same tunnel, that when something falls into a black hole, it does not simply vanish. Instead, it is flung out into the universe from a white hole, possibly in another time, another dimension, or even another universe altogether. If this is true, then every black hole is a portal to somewhere else. When a star collapses under its own gravity, it does not just die, it transforms into a cosmic gateway. And what lies beyond that gateway? Could white holes be the source of the Big Bang itself? The idea is disturbing. If a black hole's singularity leads to a white hole's outburst, then our own universe might be the result of an ancient black hole from another reality. Everything, space, time, matter, might have been expelled from a singularity in another, cosmos, an explosion that became our beginning. This would mean that the Big Bang was not a true beginning, but merely the other side of an event horizon we cannot see. And this leads to an even more terrifying question. If every black hole creates a white hole somewhere, then right now, in some distant region of space-time, new universes might be constantly being born. And if that is true, then what created the black hole that led to our universe? Was it part of an infinite chain of realities, each one birthing the next? If so, there was never a first universe, only an endless recursion of existence, with no beginning and no end. Or perhaps white holes do not exist at all. Maybe they are a cosmic illusion, a mathematical artifact that nature refuses to allow. But if that is true, why do the equations predict them so perfectly? Why would reality create an equation so precise, so undeniable, yet so impossible? There is one final chilling possibility. If white holes do exist, they may not be places at all. They may be events. Some theories suggest that when a black hole finally evaporates due to Hawking radiation, the compressed information inside does not disappear. Instead, it re-emerges in a sudden violent burst, a white hole explosion. But if this is the case, then the birth of our universe may not have been a gentle expansion. It may have been the death scream of a black hole from another reality. And if that is true, then what happens when the black holes in our universe finally fade? Will they become the seeds of new universes? Will they explode into unimaginable realms of space-time, birthing realities that can never know of us? Or worse, has this already happened? Are we merely the decayed echoes of something greater, remnants of a universe that once was, doomed to repeat the cycle forever? Imagine a universe where logic itself bends, where the fundamental principles of cause and effect begin to crack. You observe reality, certain that your deductions are sound, that your understanding of the world is built on firm ground. But what if, beneath the surface, the very act of observation warps the truth? Hardy's paradox is one of the strangest and most unsettling conundrums in quantum mechanics. It suggests that two particles can interact in a way that should be impossible, and yet when we measure them, we find that the impossible has occurred. It is a paradox that challenges not just our understanding of physics, but our trust in reality itself. To understand the horror of Hardy's paradox, you must first grasp the bizarre rules of quantum mechanics. In the microscopic world, particles do not exist in a single state until they are observed. Instead, they exist in a superposition, a ghostly limbo, where they are in multiple states at once. When measured, they are forced to choose one reality, collapsing into a definite state. But what happens when two such particles, say an electron and a positron, are brought together in a quantum experiment? According to classical intuition, they should either interact or not interact. There should be no ambiguity. Yet Hardy's paradox reveals something deeply disturbing. There are situations where these particles should annihilate each other, but when we look, we find that they both survived. This is not an experimental error. This is not a mistake in the mathematics. The paradox is built into the laws of quantum mechanics themselves. When we apply quantum theory to Hardy's experiment, it predicts a scenario in which an electron and a positron meet, should be destroyed upon contact, and yet they are still there when measured. How can this be? How can something both happen and not happen at the same time? The unsettling truth is that our observation itself may be altering the outcome. The particles, existing in a state of superposition, do not commit to a single fate until we look at them. It is as if reality hesitates, torn between two contradictory possibilities, and only makes its decision when we interfere. But this leads to a horrifying implication. If quantum mechanics allows events to be both true and false at once, then what else in reality might be built upon such contradictions? If two particles can exist in mutually exclusive states simultaneously, then what about larger systems? What about your own existence? You think you are a single definite being, moving through a concrete timeline, but if Hardy's paradox is correct, then deep beneath the surface, you may be existing in overlapping realities, simultaneously alive and dead, here and elsewhere, part of countless contradictions that your mind can never perceive. And if observation is what forces the universe to choose, then what happens when no one is looking? Perhaps at this very moment, your reality is not as stable as you think. Perhaps when you close your eyes, when you stop paying attention to the world around you, it begins to split into impossible configurations, folding into paradoxes that resolve only when you force them to. You tell yourself that this is absurd. that the world remains the same whether or not you observe it, that reality does not need you to keep it from unraveling. But that is just an assumption. You have never truly tested it. And if Hardy's paradox is any indication, assumptions about reality should never be trusted. You have always believed that information cannot simply disappear, that reality, no matter how complex, must follow a thread of continuity, that everything that happens leaves a trace, a record, an echo that cannot be erased. But what if you were wrong? What if there existed something so absolute, so final, that even the fundamental fabric of reality could not resist its pull? Welcome to the paradox of the page curve, a haunting riddle lurking at the edge of black holes, where logic, information, and existence itself are devoured into oblivion. To understand the horror of the page curve paradox, you must first confront the abyss that is a black hole. These celestial monsters, born from the deaths of massive stars, are cosmic voids of no return, where gravity is so overwhelming that nothing, not even light, can escape. And yet black holes do not just consume, they also evaporate. In 1974, Stephen Hawking made a disturbing discovery. Black holes slowly radiate energy over time, a process now known as Hawking radiation. This means that black holes are not eternal. They shrink, decay, and eventually disappear completely. But here lies the paradox. What happens to everything they swallowed? According to the rules of quantum mechanics, information can never be destroyed. It can be scrambled, transformed, or hidden, but it must always persist in some form. This is the foundation of our understanding of reality itself. If information could be lost, then cause and effect would unravel. Time would have no meaning, and the universe itself might be built on a foundation of chaos. But general relativity, the theory that governs black holes, seems to tell a different story. When a black hole vanishes, so does everything inside it, including all the information it ever consumed. It does not escape. It does not reappear elsewhere. It is simply gone. This contradiction, the impossibility of information loss versus the apparent destruction of information inside a black hole, was one of the greatest crises in theoretical physics. For decades, scientists debated whether black holes were cosmic shredders of reality itself. If information could truly be lost, then everything we think we know about the fundamental laws of the universe would be wrong. Enter physicist Don Page, a former student of Hawking, who proposed a disturbing resolution: the Page curve. Page predicted that if information is truly preserved, then the radiation a black hole emits must follow a peculiar pattern. At first, the radiation carries no information. It is completely random, as if the black hole is simply evaporating away. But then, at a critical threshold, a shift occurs. The black hole starts releasing coherent, ordered information, as if it has somehow stored everything it swallowed and is now returning it piece by piece. But how? How can a black hole emit information about what fell inside it if that information was once trapped beyond the event horizon? This is where the paradox deepens. Recent breakthroughs in quantum physics suggest a shocking possibility. The interior of a black hole may be encoded in its radiation from the very beginning. That means the event horizon does not just mark the boundary between space and oblivion. Instead, it is a cosmic mirror, a surface where everything that falls in is paradoxically still present outside in a scrambled, hidden form. This idea shatters our classical view of space and time. It suggests that information is not confined to a single place, but is somehow holographically smeared across the fabric of reality itself. But this explanation comes with a horrifying implication. If the Page curve is real, then black holes are not devourers of information. They are prisons. The knowledge of everything they consume is never truly lost, but is trapped in a distorted, fragmented state, only returning to the universe as radiation in a form no mind can comprehend. Imagine falling into a black hole. Your atoms, your consciousness, your very identity are stretched and torn apart by gravitational forces, but in some strange, unknowable way, the information that made you still lingers, encoded in the radiation, scattered across the cosmos in ways that defy understanding. Are you truly gone? Or are you trapped in a liminal state, spread thin across the universe, whispering in particles of light that no one can decipher? And if black holes can do this, then what about the universe itself? Some physicists now speculate that our entire reality may work the same way, that space and time are mere projections, reflections of a deeper, hidden structure. What we perceive as reality might be nothing more than the information playing out on a cosmic screen, an illusion of depth, just like the page curve suggests for black holes. If this is true, then what does it mean for you? Are you a being of substance, of definite existence, or merely a projection on the event horizon of some unfathomable cosmic structure? Perhaps you believe you are real, that your thoughts, your experiences, your very being are unique and self-contained. But what if, just like the information trapped in Hawking radiation, you are already scattered, already fragmented, an echo of something far greater, something just beyond your reach? And if reality is built on these paradoxes, what happens when the final piece of information is released? What happens when the universe itself evaporates? There are places in the universe where reality itself breaks down. Places where the laws of physics, the very fabric of existence, cease to function. Singularities, points of infinite density and zero volume, where time and space collapse into something utterly unknowable. You might think of black holes, those cosmic voids that swallow everything in their path, as terrifying anomalies. But here's the unsettling truth. Black holes are not the problem. They are merely the curtains hiding something far more disturbing behind them. A black hole's event horizon acts like a veil, a one-way barrier beyond which no information can escape. Whatever falls in, light, matter, even time itself, is lost forever. But that event horizon serves an even darker purpose. It hides the singularity. A singularity is not just a point of infinite gravity. It is a tear in reality. A place where all known laws of physics fail, where equations break down, where time and space dissolve into an unknowable chaos. In theory, nothing prevents these singularities from existing naked, fully exposed to the universe, radiating their madness into the cosmos. But here's where the cosmic censorship hypothesis comes in. Proposed by physicist Roger Penrose, this hypothesis suggests that nature has a safeguard, that every singularity must be hidden behind an event horizon, that the universe does not permit the exposure of its deepest truths, that singularities can exist, but only concealed. But why? Why would the universe impose a kind of censorship on its own extreme realities? What happens if that veil is lifted? The possibility of a naked singularity is one of the most unsettling concepts in modern physics. Because if a singularity were ever to be exposed, if its raw chaos were to interact with the rest of the universe, then all of physics, everything we know about cause and effect, could collapse. Reality itself might become unpredictable. Imagine a place where time does not move forward, where the past and future lose all meaning, where space stretches and warps infinitely, a place where light itself could be frozen in time. or where events could unfold without any cause at all. If naked singularities exist, then they might unleash effects that ripple across the cosmos, rewriting the fundamental rules of existence. Reality where information does not behave as it should. A reality where anything could happen, without warning, without reason. Physicists have searched for proof of these hidden singularities, using the universe itself as a laboratory. Black holes, neutron stars, gravitational waves, all have been studied in the hopes of finding a crack in the cosmic censorship. So far, no naked singularities have been observed. But that doesn't mean they don't exist. There are theoretical loopholes, specific conditions where singularities could emerge, exposed and unrestrained. Some solutions in Einstein's equations allow for them. Certain types of extreme gravitational collapse might give birth to them. And then there's the biggest mystery of all, the Big Bang itself. The beginning of the universe was, by all accounts, a singularity. But unlike black holes, this singularity was not hidden behind an event horizon. It was, in every sense, naked. The entire cosmos was born from an exposed singularity, and that raises a terrifying question. What if another one appears? What if, somewhere in the depths of space, an event occurs that tears the veil away? What if a singularity is uncovered, its madness spilling into the observable universe? Would we even recognize what was happening? Or would reality simply shift? Imperceptibly, at first, then violently, until everything we know is rewritten. Perhaps the universe enforces its censorship for a reason. Perhaps we are not meant to see what lies beyond. And if we ever do, if the veil is lifted, will it be the end of reality as we understand it, or the beginning of something entirely new? There is a boundary between what we can control and what we cannot. A fragile thread separating the known from the unknowable. You believe, perhaps instinctively, that reality is something you can grasp, that cause leads to effect, that actions have consequences, and that the physical world is not some elusive specter slipping through your fingers. But what if reality is not so cooperative? What if, at the smallest scales, the mere act of observing something does not just reveal its properties, it forces them into existence? What if two distant particles, separated by vast cosmic distances, could respond to each other instantaneously, as if they were one and the same? This is the unsettling realm of the EPR steering paradox, a quantum nightmare first conceived by Albert Einstein, Boris Podolsky, and Nathan Rosen in 1935. It was meant to expose a flaw in quantum mechanics, to prove that the theory was incomplete, that there must be some deeper reality guiding the chaos beneath. Instead, it revealed something far more disturbing. To understand the paradox, we begin with entanglement, a phenomenon so bizarre that even Einstein himself dismissed it as spooky action at a distance. Imagine two particles, once connected, now separated by light years. According to quantum mechanics, these particles are not independent. They share the same existence. Measure one, and the other instantaneously adopts a correlated state, no matter how far apart they are. This defies classical logic. How can one particle know what has happened to the other faster than the speed of light? How can information travel instantaneously across space, violating everything we understand about causality? But the EPR steering paradox takes it further. It is not just that these particles are mysteriously connected. It is that one can force the other into a definite state. Picture this. You hold one of the entangled particles in your hand. Until you measure it, it exists in a strange superposition, a ghostly blur of possibilities. The moment you observe it, reality locks into place, but not just for your particle. The distant twin, light years away, is also forced into a definite state at the exact same moment. This is where the paradox emerges. Quantum mechanics suggests that before measurement, these properties are not real. They do not exist. They are not hidden, waiting to be revealed. They are undefined, as if reality itself has not yet decided what they should be. Your observation does not just uncover the truth, it creates it. Think about what that means. By merely choosing what to measure, you exert control over something infinitely distant, something that should be beyond your reach. It is as if you have reached across the void and steered reality itself, not by touching it, not by sending a signal, but by the mere act of looking. But here's the horror. What if reality is doing the same thing to you? If a distant observer had access to an entangled pair, could they manipulate your reality without ever interacting with you directly? Could the fundamental nature of your world be shaped, guided, or even rewritten simply because someone, somewhere, has chosen to look? This is where the paradox becomes truly unsettling. Quantum mechanics does not merely challenge our understanding of space and time, it undermines the very notion of objective reality. The idea that things exist independently of observation collapses under the weight of entanglement. Reality is not a fixed structure, it is a dynamic, shifting, observer-dependent phenomenon. And if that is true, then what are you? Are you an independent entity, existing whether or not anyone is watching? Or are you, like an entangled particle, nothing more than a possibility, a collection of uncertain states, waiting for some unseen force to steer you into being? And if you are being observed, then by whom? Imagine waking up one day to find that everything is happening in reverse. Time is flowing backward, actions are undoing themselves, and causes are becoming consequences. The words you speak are unspoken, your steps retrace themselves, and every moment collapses into the one before it. You are not reliving the past, you are unliving it. At first, you might assume this is some strange trick of perception, a temporary distortion in the way you experience time. But then you realize, it is not just you. The entire universe is shifting in reverse, as if an unseen force is unwinding reality itself. The past is no longer behind you, it is ahead, waiting to be reassembled in perfect sequence, piece by piece. This is the reversal paradox, a fundamental contradiction hidden deep within the very fabric of physics. It challenges our most basic assumptions about time, causality, and entropy. If every physical law remains unchanged when reversed, if nothing truly prevents the universe from running backward, then why does time only move forward? Why is your experience of reality locked in a single direction? At the core of this paradox lies the concept of time symmetry. Most physical equations do not distinguish between past and future. The laws of motion, electromagnetism, even quantum mechanics, they all work just as well in reverse. If you recorded a billiard ball bouncing off another and played the footage backward, the motion would still look completely natural. But reality does not behave that way. There is an irreversibility to existence that defies explanation. A shattered glass does not spontaneously reassemble. A burnt match does not reignite and return to its original form. The arrow of time points forward relentlessly, as if an unseen force is pulling everything toward an inevitable end. This force is called entropy, the measure of disorder in a system. According to the second law of thermodynamics, entropy always increases over time. Things break down, not the other way around. order dissolves into chaos, and the universe slides further into irreversible decay. But here's the problem. Why? Why should entropy increase at all? If the laws of physics allow for reversibility, why does time insist on flowing in only one direction? What mechanism forces the future to be different from the past? The deeper you dig, the more unsettling the questions become. Some physicists argue that entropy is just an illusion, that at a fundamental level, time does not actually move at all. Instead, every moment, past and future, exists simultaneously, like pages in a book. Your experience of time flowing forward is merely a limitation of perception, an artifact of how your mind organizes information. But what if this is wrong? What if time is not an illusion, but something far more disturbing? Imagine a universe where reversal is not just possible, but inevitable. Every action you take will one day be undone, every thought unthought, every moment unwound until you return to the nothingness from which you came. In such a reality, death is not an end, but a reversal, a process of unwriting, where your existence is erased step by step until you were never born at all. And if time can reverse, then how do you know it has not already? Perhaps you have lived this life before, only in the opposite direction. Perhaps you are already undoing yourself. Every experience a ghostly echo of something that was once real but is now fading. If reality is truly reversible, then how can you be certain that your present moment is not someone else's past? And if time can flow forward and backward without contradiction, then what exactly is stopping it from collapsing entirely? There is something unsettling about the nature of time. Not just the way it moves forward, but the way it begins. You exist in a universe that is already billions of years old. Yet when you look around, everything seems remarkably young. Stars are still forming, galaxies are still assembling, and life, especially intelligent life, seems to have only just begun. But why? If the universe is truly infinite, if time stretches endlessly into the past, then shouldn't the cosmos be ancient beyond comprehension? Shouldn't civilizations have already risen, dominated, and transcended existence countless times over? And yet, you find yourself here, at the very start of something, as if reality itself has only recently begun. This is the Youngness Paradox, a chilling contradiction that calls into question everything we assume about time, existence, and our place within it. To understand this paradox, consider the cosmic timeline. The universe, as we know it, is roughly 13.8 billion years old. That might sound like a vast expanse of time, but in the grand scale of infinity, it is nothing. If existence has no true beginning, if time stretches backward without limit, then why is the universe still in its early stages? Shouldn't we exist in a cosmos that has aged to the point of complete exhaustion? Now, look at life. The Earth is 4.5 billion years old, yet complex life only emerged a few 100 million years ago. And intelligent life? Humans have only existed for a fraction of that time, less than 0.01% of Earth's history. And it's not just Earth. As far as we can tell, intelligent civilizations across the universe, if they exist at all, are either extremely rare or extremely young. But that is where the horror begins. If life has been possible for billions, perhaps trillions of years, then why are we appearing only now? Why aren't we seeing the ruins of civilizations that should have existed long before us? Why is history so shallow when time is so deep? There are only a few possible answers to this, and none of them are comforting. One possibility is that we are the first, not just on Earth, but in the entire universe, that somehow, despite infinite opportunities, intelligent life simply never formed until now. But that would be absurd, wouldn't it? With infinite past time, even the rarest event should have happened an infinite number of times already. Another possibility is far more disturbing. Something is resetting reality. What if civilizations never grow old because something erases them before they reach true antiquity? Some unknown force, cosmic disasters, self-destruction, or something more sinister could be ensuring that no intelligence ever lasts long enough to make it past this point. That would mean we are standing at the edge of an abyss, at the last moment before an inevitable end. But then there is a third, even more terrifying explanation. What if time is not what we think it is? What if the past is an illusion, a manufactured construct that only appears to stretch backward, but in reality was never there at all? What if history itself is a fabrication, a set of carefully placed memories and artifacts designed to create the illusion of a past that never truly existed? If that were true, then how could you ever be certain that you are not the first? That this moment right now is not the very first moment to ever exist. And if it is, if reality is only just beginning, then who or what created it? And more importantly, why? And now we arrive at the final paradox, the one that lingers beyond the script, beyond the mind, beyond even the grasp of comprehension. After traversing the strangest corridors of reality, after questioning time, existence, thought, and perception itself, you must ask, what now? Perhaps, as you lay in the dark, surrounded by silence, your mind is already tangled in these paradoxes. Perhaps a part of you feels trapped, as if something irreversible has shifted. You are no longer the same person who began listening to this. The way you see the world, the way you experience reality, has changed in ways you cannot fully articulate. And therein lies the final paradox. You can never go back. You cannot unknow what you now know. You cannot unthink the thoughts that have nested themselves into your consciousness. You cannot erase the creeping suspicion that reality is not what it seems, that something, somewhere, is fundamentally off. Are you awake? Are you real? Is anything? Maybe. For now, the best you can do is close your eyes and let the questions dissolve into sleep. Or perhaps they will follow you even there.